Hello again. Today I will share to you another interesting forensic artifact called Shimcache. So, just a quick background. So Shimcache is designed by Windows for compatibility check. So imagine we have different Windows version, Windows 7, Windows 8, Windows 10, and even the server version starting earlier 2000, 2003, 2008 up to 2022. Those varying versions have slightly different architecture, and imagine the challenge of running an executable that is compatible to all those OS versions. So Microsoft introduced a mechanism called Shimcache. So Shimcache, it's a mechanism to allow running an executable in the context of different operating system. So to ensure compatibility. So first, I'll give you a more comprehensive background. So this is actually the Shimcache characteristics. So when a program is run, when it is shimmed, it has a corresponding registry updates. So it will write registry in the memory on runtime, and then each executable is always checked and added to registry, regardless of whether it has been shimmed before. So like prefetch, Windows holds certain number of Shimcache entries before deleting or rotating the oldest one. So we have here the summary for XP, it's up to 96 entries. And then for 2003, server 2003, we have 512. For server 2008 and above, and then for Windows 7 and above, we have 1024. So as mentioned, this is a very volatile evidence or artifact. It's written in the registry memory during runtime, and if we want to flash or store it on the disk, a reboot or shutdown is needed. And then Shimcache entries have executable flag to show for some OS to show if it was executed. But take note, the last modification time of executable is not always the last execution time. So for execution, it's always better to correlate it with other artifact like prefetch. And here is the registry path for the Shimcache. So it just varies per OS, but basically the XP is only slightly different and the rest of the OS versions are the same. And of course, what is the value of the Shimcache for our forensic investigation? So it's help us track executable if it has been present on the system or possibly executed. And it tracks the last modification date of the file path, and if it was executed. So applicable only to some OS version, particularly XP. For the newer, this is not often seen. I'll show you later. And then if the executable is renamed, moved, or copied, it will be shimmed again. So regardless, like in the characteristic, regardless if it has been shimmed before. So this is very valuable for investigating file replication, or binary replication to multiple location. For example, worm or malware or backdoor propagation, attacker tool implantation, the different machines or location, or even detecting time-stamping attacks. For cases where binary slash modification is not equal to the Shimcache. Anyway, time-stamping is a pretty advanced technique, but it's quite easy to do. But the goal is to confuse investigator or forensicator as to the actual attack timeline. Okay, so enough with the boring details. So let's show what an actual Shimcache looks like. So I have here a parse c temp. Oh, I have here a sample Shimcache data. So this is what a Shimcache entry looks like. Just give it a time to load. Okay, wait a minute. Okay, there you go. Okay, what happened? Okay, notice here, this is the actual Shimcache entries as parsed by the R tool. So you can see here the control set, the entry position, we have here the executed plug, and the last modified time in UTC. And here's the actual path of the executable. Okay, and then if you are adept in Windows, one point or another, you have encountered this compatibility. I'll show you. When you click on the properties of an executable, we have here the compatibility tab. And here, this is the mechanism of Windows to run an executable in the context of another operating system to ensure compatibility. So each mode here is called Shim. Okay, so this is actually the Shim mechanism. Okay, and in the memory, in the registry, the actual location is, as mentioned here, this one, in the HT local machine system, current control set, control, session manager, app compat cache. So this is the actual Shim cache or app compat cache. And if we open this, it's not really easy to understand using registry editor. But we can see bits and pieces. For example, here we can see the desktop calc.exe copy.exe. So this is that executable located in desktop calc_copy.exe. We can actually read bits and pieces, but we really need a parser in order to investigate it effectively. So how do we really parse Shimcache? So there's this tool called AppCompat Cache Parser. So I have here open. You can download it. This is, by the way, created by Sans instructor Eric Zimmerman. So Sans free tools are amazing due to its efficiency and very fast to process or parse artifacts. So it's right here. I have it. So just go, in order to install it, simply go to the Eric Zimmerman's website, tools, and you can download the AppCompat Cache Parser binary directly. Just extract it on your machine, and then to use it really, simply browse. So simply browse on the location of the binary, and then you can type the exact binary to show the help or the switch commands, the options that you could do, the tool. And then we have here the examples. So the first example, this one, when you run this, it will automatically parse all Shimcache entries on the machine and output it on the ctemp directory. So I already executed it. So you can see, once it's successful, it will show you that results is saved to that location you have specified. And that's the one I have opened here. So this is more human readable compared to the raw registry entry here. So that's how easy it is. So and then I actually made a little demo, or I'll show you a little demo. So let's say for example, okay, this will need quite a restart. Let's say for example, I will uh, okay, I will duplicate timeline explorer.exe to another location. So notice here, I will duplicate this in the downloads folder and I will rename it to notepad.exe. Okay, and then I will execute it on this new directory where I copied the timeline explorer.exe. Okay, let's just give it some time. Okay, so regardless, so imagine if this is an actual malware. So remember, I have copied it, moved it to another directory, and executed it under a different file name. So let's try now to see if it will be reflected in the Shimcache entry. So recall in our earlier concepts discussion, Shimcache entry is written in memory during runtime. So if we parse it now, we cannot find it because it's not yet flashed to disk. This is still on the memory. So I'll show you. So this will parse a new file containing all Shimcache entries. Okay, so that's done. So let's go to the temp, ctemp. This is the newest file. So open it. Okay, let's try it again. Oh, it already opened. Okay, so let's try to find that notepad.exe. Notepad. Okay, as you can see here, our executable was not yet shim into the disk. So remember the one we have copied, this one, notepad.exe, which is actually a timeline explorer executable. See here, file description, time explorer, and we cannot find it. Just to confirm that it will be flashed into disk after a reboot. So let's simulate a reboot. Okay, I'll fast forward this. Okay, so done rebooting. Let's just sign in again. And let's try to parse that. It tries to parse the Shimcache again to see if we can now see the copied timeline explorer .exe, which is renamed to notepad.exe, as I have demoed a while ago. So here we have the notepad. Okay, it's still there. So let's go to the C. Okay, let's go to the directory where the parser is located. Then, okay, just check the menu. We can to get the actual command used for parsing. And just copy it here, copy here. Let's try that again. Okay, it's done. So let's check. ctemp. Okay, we now have here the latest. Open it. Okay, the filter is still there. Okay, the filter is still there, but notice this time. What do you notice this time? Notice here we already have the notepad.exe in the downloads folder. So it has seen now the notepad.exe. So I'll just show you. I'm actually using Timeline Explorer. So I'll, I'll just mark it to remain it on the filter. So okay, where's my filter? Oh, sorry. Okay, search option. Let's try again. Now let's try to search for the Timeline Explorer. Okay, I'll just show you the Timeline Explorer. So, and then let's compare later. So notice here, it's located in the C forensic program files. And then we are to filter the notepad.exe. This is the copied Timeline Explorer under Downloads folder. So remember, uh, how do we know just by glancing here that this notepad.exe is a timeline explorer.exe? So from the perspective of Shimcache, it has the same last modification date on its Shimcache entry. So more or less, those are the same file. So another indicator is that check its file size. So given that you have initial clue that they may seem similar file due to the very same last modification date up to the seconds. So imagine it's basically impossible or rarely that the same file on a different location or two different file on two different location will have the same um, timestamp, last modification timestamp up to the second level. So, of course, if you are the one investigating, you will verify the size as well. So, to verify the size, go to downloads. Let's see the size. Okay, the size is 62628. 62628. And how about the size of, okay, let's open a new one. How about the size of the actual Timeline Explorer? So we will see it in C. Then Zimmerman Timeline Explorer. Okay, so notice here, this confirms our, just imagine if you have no prior, no prior knowledge that we have copy paste this one to the downloads folder, just by investigating the Shimcache, you could tie them up that they are basically the same file. So given the same modification date and the same size. So if this is a malware or worm, typically it will propagate from one location to another. Or if this is an attacker, it will plant, the attacker will plant its attacker tools or backdoors to different location, and oftentimes they won't bother to change the timestamp, but if they do, you will see a different date modification time on the MFT compared to the date last modification time in the Shimcache. So you will see it only, of course, it will be used by very advanced attackers, the time stamping technique. But if you've been following along since the start of this lecture, definitely you can use Shimcache to discover how the executable propagate or was copied or renamed from one location to another. So, and you can even detect uh, timestamp activity if there's a variance or deviation with the last modification time in the Shimcache and in the MFT. Okay, so hope you learned some